Is this better?
Yep, that's perfect.
Are you seeing? Okay, good. So, wait, okay. So birds are related to happiness in people. I put this picture first because the World Economic Forum just published this study that in Europe showed that the number of bird species around people's homes was directly related to their general happiness in a way that was very similar to increase in salary or in income. And that was very surprising to me. I always knew birds make me happy, but it wasn't clear to me that so many people in Europe and elsewhere really find that their happiness at home relates to birds. We know that people's happiness relates to nature. There are studies even on people in hospitals show that their recovery is a lot faster when they see nature out the window rather than an urban landscape. But I was really kind of gratified to see that birds specifically make people happy. I know that this is true for me. And in Sunnyvale, and I thought I should show you this, or in Santa Clara County, there are places where people go to see birds specifically. And one of those places is Sunnyvale. And Sunnyvale here has two, numbers 7 and 8 on the top hotspots out of 100 places that people go to visit birds and view them. And so this is how many bird species were seen there. So we see in the Sunnyvale Water Pollution Control Plant, it's 123 species, and Sunnyvale Valence Park is 222. The reason why there's so many birds in Sunnyvale is because the birds migrate along the bay. They get to kind of the bottom of the bay or the end of the bay and they stop over. Or they stop there before they fly north on their migration north. So Sunnyvale is actually important to birds. And I would think that this extends to the entire Bay Area. Anywhere that there's water, there's birds, and also in people's backyards and so on. And these are the migration routes. And I think people are not always aware that birds do these migrations that are really long flights between where they winter and where they breed. So we in the West Coast are in the Pacific Flyway, which is shown in red here. And birds can migrate all the way from Alaska to the end of the continent in Argentina and Chile. They fly long, thousands of miles. And birds usually migrate at night. And the reasons for that, some people think it's because they're less visible, but what physiology shows is that if the birds fly during the day, flying generates a lot of heat. It's a very energy demanding activity like running. And so if they fly during the day, they may not be able to dissipate all this heat and they'll just overheat. So flying at night solves that problem. But flying at night exposes them to other risks, and I'll get to that in a little bit. So here I just thought I'll show you a couple of those migration. This is ruby-crowned kinglet, quite common in Sunnyvale and the Bay Area. And you can see in this video that during, this is like in January, you'll see in January, the birds are in the south and they start migrating north. Then they breed in the north country and then they come back to winter in the south of the continent of North America. So here it goes again. And people don't really realize that those tiny little birds, which are like 3 inches long barely, can make these huge migrations. So here is another one. This is a golden crown sparrow. Golden crown sparrows are pretty common as well in our area, but they're really limited to the West Coast in their distribution. And again, you can see that they're around the Bay Area in winter, and then they migrate to Alaska to breed, and then they'll come back the next winter. And these are thousands of miles that those little birds can fly, and there is a lot of obstacles in the way. And so the threat to both local birds and migratory birds generally are loss of habitat and migration rest areas where they can get food and water and shelter. Collision with glass is a very large issue for birds. It is estimated now that hundreds of millions of birds are killed because of collisions with glass and other man-made structures every year. And artificial light at night, which is most of what I'll talk about today. And that because it attracts them to hazardous situations, it interferes with their navigation and it disorients them. And there are physiological behavioral impacts on birds, just like on people, that I'll talk about later. Climate change, obviously, is a big threat to any critter that depends on predictability of resources and weather. Depredation by cats and poisoning also issues that they have to contend with. And collisions are a big deal. In Sunnyvale, there are some guidelines or standards in buildings, new buildings, that try to minimize bird collision, but they're not completely stopping it. This little bird is the one we saw before, the ruby-crowned sparrow, and I actually found it in Sunnyvale. And collisions occur anywhere that the birds are active, especially if they're attracted to that site because of light. And migratory and young birds are very vulnerable, and the light and glass are pretty deadly for birds. Now I'll get to the light part that is not only birds, but this is what we evolved with. We humans and every living thing evolved under a very dark sky. We could see the Milky Way, we could see the stars, and this picture was taken on Skyline Boulevard above Cupertino, so some of you may be familiar with that. I saw some of your people, your group are people from Cupertino, so this is something you may be familiar with. And that is what birds used to navigate. People used to navigate by the stars as well. But there is something very beautiful about being able to see the sky. And these days, because of light pollution, it is estimated that about 80% of people in North America cannot actually see the sky. And this is what our Bay Area looks like from space. I got this just recently from Google Earth at night, and you can see the light pollution or the light, how lit our environment is and how bright. And this is a problem for birds, obviously, but for people as well. So I wanted to briefly kind of explain the difference between artificial light at night in general, and light pollution. And keep in mind, I'm talking mostly about outdoor light, because obviously we all have light in our house and on our cell phones and laptops and whatever else we use for communication and entertainment. So artificial light at night is basically all the light that intentionally or unintentionally lights up our environment at night. So this can come from buildings and street lights and vehicles, headlights and art and landscaping, parking lots, oil rigs, bridges, everything that we light up, either because we want to use that light to see something or highlight it, or because the light just escapes. And light pollution is a little different. It's really the excessive or the wasted light. It includes glare, which is when the light is too bright, sky glow, when the light is reflected from the night sky or from clouds, trespass, where light is highlighting or illuminating areas that were not intended to be illuminated, like your neighbor's yard, and clutter, where there's just a lot of different sources of light altogether, causing kind of what we saw in the picture of what the Bay Area looks like at night. So keep in mind that the impacts of light are not limited to light pollution, but that's where we have the opportunity to really make an impact. The artificial light at night, we can reduce it, but it's basically intentional. Whether that's always good intent or not, we can talk about later. Light pollution is basically not intentional and should be avoided and reduced consistently. So the International Dark Sky Association estimates that at least 30% of all outdoor lighting in the US is wasted energy, mostly because lights are not shielded. They estimate that it's 3.3 billion in the release in cost, and the release of 21 million tons of carbon dioxide each year. This estimate is a little old, and I haven't been able to find newer estimates. And if any of you like that challenge, it would be interesting. But you can see in this picture that they provide that you have light that they consider to be worse because there is no protection of dark sky. There are some that are still allowing some light to escape, cutoff, which they consider good, and full cutoff, which they consider best. I have to say that I think that we need to even go below that, because now we have technologies that allow light to be used only when we need it, and you can trigger it by motion sensors or timers, or dim it when you don't need it. So there's many ways these days that we can improve the situation more than what we see here. So, and one of the things that I haven't mentioned is because of the change from the traditional lighting, which was sort of yellowish, to LEDs, the light that we produce becomes whiter. It's cheaper, so we use a lot more of it. We use it pervasively, more than we need. It becomes something that is just used because we can, and it's cheap, so you don't need to worry about it. So the Dark Sky Association and other dark sky advocates say, well, use only the light that you need, direct it to where you need it, use just as much as you need and not more, shield the light so the light doesn't project to above, use timers and other sensors to use the light when you need it and have it turn off when you don't, choose relatively warm light lamps or fixtures, and I'll talk about that more later, and keep the light to where you want it and don't let it spill over to the sky or to the neighbors. From a dark sky and energy consideration, this is good if people did that. I think that there are a lot of things that people kind of don't think about necessarily, which is, down at the ground level, in some areas, there's also a lot of critters that live there and the light would interfere with them. But it's definitely better than the alternative, which is light up everything. And I want to get a little bit into the biological effects of light in general, and not only light pollution. The response to light is evolutionary. Every cell responds to light. It started when the first cells swam in the ocean, and with the light and dark cycles, they swam up and down in the water column. They still do. Plankton still do that. Many other marine and aquatic insects, aquatic critters still do it, and people and all animals and plants actually respond to lighting, both on the circadian rhythm, which is light in the day and the night, and the length and the changes in light with seasons. So the daily and the seasonal changes provide cues for our biological function and behavior. And this is because the exposure to light at night, or the response to light, triggers gene expression and hormone regulation. And when the light is triggering the hormone or suppressing hormone regulation and gene expression at the wrong time of day or night, that can cause disease. Specifically for insects and birds, there is an attraction to light that is quite deadly if they're attracted to the wrong place or at the wrong time, or both. So I'll get into all of that a little bit more. Here are some studies that show the biological impacts. These studies are pretty recent, from the last 3 years or so. One shows a seasonal association with urban light pollution for birds that migrate at night, and shows very strong association. The birds are actually attracted to the cities because of light pollution. And these two studies kind of discuss that. There are others that some of the findings are pretty surprising. Again, all of these studies are really recent. So suppression of melatonin production in human and animals is one of the reasons why there's so many behavioral impacts and other physiological responses. There are for the insect decline, which we now call the insect apocalypse, because so many insects are disappearing from the planet. The light keeps birds awake at night. It increases biting behavior in mosquitoes, Aedes aegypti, where they did this study. And there was another study just published this month, I think, in February, in March 2021, that shows increasing biting behavior in these mosquitoes that cause West Nile disease, which we know is a problem in this area, and they often spray our area for mosquitoes because of it. Artificial light at night affects plants as well. In this study that was just published a few days ago, artificial light affects plant pollination even during the daylight. So the impact of pollination can really affect our food system. There are the impact of light on, and there are other studies that show that artificial light at night disrupts the synchrony between when the plants flower and when the insects are there to pollinate them. So we're losing pollination, which is really the basis of our food system. So what does it do to humans? This is a picture from Cupertino, by the way. In humans, we see that artificial light at night is linked to various diseases and other impacts to health. And I want to say that some of these studies really that I've seen really look at indoor lighting, but a lot of them also look at artificial light outside and the exposure of people to light in their environment, which is not necessarily, using devices or watching TV or being at home in a lit environment. And beyond sleep disorders, which we're kind of familiar with, it's hard to sleep in light. There is really strong links to breast cancer, prostate cancer, thyroid cancer, obesity, diabetes, affective and mood disorder, anxiety, depression, various types of behaviors that are associated with autism spectrum. Recently, like just last month, they showed another one that links it to premature birth. So the impacts on our physiology are pervasive and strong. And I think that when I started looking at this and like, why aren't we more aware of it? Why aren't we doing something about this? I think it seems kind of like sugar. People like sugar. They just use it to celebrate. They use it to enjoy life. And light in some ways is the same thing, and also it's not very healthy. So here are some of the latest articles that I found in the last, again, pretty recent. Light at night increases the breast cancer risk worldwide. And then on the other side of that, total darkness is a key to the success of breast cancer treatment and therapy. By now, I think scientists really don't like using the word causation. They like linked to, but there seem to be quite strong evidence that artificial light at night is causing, to some extent, not the only thing, probably breast and prostate cancer. And then, I just saw this study that came, and here is the popular study, sorry. But the study itself showed, they studied more than 200,000 people. And they showed that living in areas that have a lot of light, or even near street lamps, increases the risk of thyroid cancer by 55%. And light pollution was also linked to preterm birth. And both these issues are on the increase in the United States, both thyroid cancer and premature birth. So the next slide, I want to talk a little bit about the spectrum of light, because not all light impacts us in the same way. A lot of the impacts of light, both the attraction for insects and birds, as well as the physiological impact to all living things, really are linked to the wavelength, or as it is measured by correlated color temperature. So the next slide, I'll talk about that a little bit. And if anything is confusing or unclear, just interrupt and ask questions. So the light spectrum, what you see here is 4 graphs of different of light in a spectrum of the light, measured in Kelvin, which is a measure of the correlated color temperature. And you can see at 5,000 Kelvin, we have a little bit of red light, a light in the green area, and a very strong blue light peak. Overall, the light looks very white, but if you break it to the component of that light, this is what you see. The blue light is what is implicated in melatonin suppression, which is one of the main reasons for all the diseases that we see and the health impacts. Our old lights that used to be, before they used LED, the lights used to be pretty much yellow and red peaks here and no blue peak at all. And those lights would still attract insects and birds, but they didn't have the blue peak that is harmful to health. They still have the problem of attraction. When you go to 4,000 Kelvin, you see that there is still a pretty pronounced blue peak. When you go to 3,000, the blue peak is a little smaller. The green and red are larger. Overall, remember, this looks white. And when you go to 2,700 Kelvin, the blue peak is even smaller. And again, the light looks a little yellowish. Not really yellow, just kind of not as white. So the damage, and this would be what they call cold light, which has a low temperature correlated color temperature versus the warm light with like 5,000 Kelvin. And so the cold light is less biologically damaging than the warm light. The International Dark Sky Association, until about a week ago, recommended that not to go over, sorry, to go back to that, it keeps jumping, recommended no more than 3,000 Kelvin for street lights and for all lights really. And they recommended, but did not quantify, even less near sensitive areas. Wildlife expert says 2,200. And then last week, the International Dark Sky Association reduced their recommendation to 2,200 Kelvin. 2,200 Kelvin is rather yellowish. The fixtures that we have available for LED today, it's very difficult to get to 22. It's possible, but it's difficult. But now there are a lot at the 2,700 range. So I would generally recommend to cities to use the lights that are less, not at the 400 and 5,000 Kelvin, but 2,700 or less. That is not what we see around us today. And a lot of people actually complain about the street lights that changed and became so bright and so white. So there was a study that I think was really, really interesting in Tucson in 2019. Tucson has dimmable lights, which is a really good thing because they can actually do these experiments and they can dim the lights in the streets. And usually their lights were at 90% of the ability, like how bright they can be. And for 10 days, they changed them, and not all the time, but I won't get into all their experimental design. They changed it to 30% of the, dimmed it to 30% of normal. And they did that with about 14,000 of about 20,000 street lights. And they found some really interesting things. They found first that people didn't notice. And people don't notice because our eyes are very adaptable and we can adjust to dark, and we can pretty much see even when the street is not as bright. They also found out that there was no increase in accidents, no increase in crime, no increase in any kind of complaints about it. Nobody sued the city because they tripped, nothing. It didn't make any difference in terms of how people responded. And as I said, most people did not even notice. The other thing that they talk about, but I haven't been able to find the numbers, is a real strong, big reduction in cost to the city in use of energy when you use a third of what you would otherwise. So this is some of the finding. One other very interesting thing that they found was that the streetlights really were not the main, and this was all measured by satellites, but the streetlights was not the most prominent light source. What they found was that the streetlights were less than 20% of the light pollution came from streetlights. And the rest of it came from all the other urban type of big city life, whether it's buildings or street cars and driving on the street, a lot of signs, a lot of parking lots, a lot of people just lighting up their front porch. All these things had 80% plus of the light pollution in this study in Tucson. And this was only published at the end of last year. So a lot of this stuff that I'm showing you is really cutting edge. A lot of studies just coming up now. Yesterday, there was a huge study, like voluminous, about impact on human health, and I haven't even had a chance to read it yet. So there is one expert that talks about the color of light at night and how to do it better, and he gave a talk recently. His name is Travis Longcore, and I just put it here because if you want more information, I'd be happy to provide you with that. He presented it to some, I don't know, this is kind of remnant. I'll get to policy a little bit. A few years ago, probably in 2017 or 18, Santa Clara Valley Audubon, me, went to the city of Sunnyvale and asked them to do a study issue on lighting and to reduce them and to develop policy and potentially an ordinance to reduce light pollution in the city. And Nancy helped. And they did. They agreed to do a study issue, and this year they dropped it. They just never budgeted it, and they dropped it. And I think that's really disappointing. And I would have loved to see that they do two things. One is really look at the lighting in Sunnyvale streets, which is in some areas really overlit, overbright, and unnecessary. And look at what people do in their own on their own properties, and not just people, like property owners of different kinds. In Cupertino, those of you that are from Cupertino passed bird safety and dark sky ordinance first hearing in March, just a couple of weeks ago. And it's going to go back to council for second hearing and approval, probably, well, I don't remember the date, but sometime in April. So Cupertino is doing well, Sunnyvale, not so much. And then I want to get to a specific project in San Jose, which those of you from San Jose, if you're willing to help, I would appreciate all of the help I can get. So in San Jose, about 100 years ago, a little more, was the end of the San Jose Electric Light Tower. It was 137 feet tall. It had very shiny, bright light at the top of it and some other lights. And it was visible all the way to San Francisco, bright, you know, this is from Wikipedia, what I have here. And in the Wikipedia, it says that a farmer complained that it interfered with laying hens by confusing them. We know that light interferes with egg laying. But they also said that the police on the beat would made money selling birds that collided with the tower to restaurants. There's so many of them. And I dug up some of the old references, and they would describe how they, there were days that they would go out there and pick buckets and buckets of dead birds that were attracted to this light and died. And a few years later, come to about 2 or 3 years ago, a group of entrepreneurs in San Jose decided to give a gift to the city and recreate this thing. And we asked the city, Audubon and Sierra Club and others, asked the city to be very careful with light pollution and to be very careful where you site something like this. Where do you locate it? And they decided to do this. Breeze of Innovation is the project moving ahead. It's in Arena Green Park, which is on the confluence of 2 rivers, the Guadalupe River and Los Gatos Creek. When you think about where birds migrate, primarily they would migrate around waterways, like I said before. So this is a migration area, important migration site. And this, to me, it's 200 feet tall. It's a gigantic structure that would attract birds to their death from far, far away. Not only that, Arena Green is close to the airport, and who wants to attract so many birds to an airport? And let's see why. So this is from New York. This is the Tribute to Light 9/11 Memorial. When these beams shine up once a year on 9/11, and the birds are attracted to the light. So what you saw there is birds trapped in the plume. What happens is the birds are attracted to the light, they see their way in, but they always come back. They circle around, they become disoriented. If there are buildings nearby, they'll probably hit them. If there aren't, they'll just fly until they're exhausted and drop dead. So there was a study done on this for 7 years, 7 nights, because 7 years. They studied the migratory birds that are flying in this plume. And they showed, this is one night in 2015, September 12, between September 11 and 12, 2015. And what they showed, here is the Tribute of Light sculpture. And when it's off, there were about 500 birds within half a mile of that. When they turned it on, there within 20 minutes, they had 15,700 birds in that radius of half a kilometer, which is pretty significant if you're near an airport. And we know that airports and birds are not really very compatible. We've been trying to oppose this project for a very long time, unsuccessfully. They had environmental leaders participate in various meetings and task forces and all that. And every time we say, well, this is the wrong place and we really shouldn't use light. And at the end, they come up and, oh, well, the environmentalists were part of the process and they love it. Well, we don't. So how can you help? And this is just my last slide. There are 2 things. One is Sunnyvale City Council, either on the 30th or probably on the 30th coming up. Ask the city to prioritize and budget the study item and not just drop it. And the San Jose Light Tower, it goes to the Parks Commission on the 7th of April. And it's going to go to City Council in early May. What the city in San Jose will be asked to do is to confirm the location and move ahead to environmental review, which means that there's still a way ahead. It's not final. They're not going to approve the project at this time, but any step forward is a step in the wrong direction as far as we can tell. And so, yeah, that's me. You can find me at advocate@scvas.org. It's like Santa Clara Valley Audubon Society. Anyone wants my contact information, Nancy is welcome to provide that. And I'm not sure how to, I'll do